The first type of reaction we'll talk about is a combustion reaction, specifically the combustion of a hydrocarbon, which contains only hydrogen and carbon, or of a compound that contains only the elements carbon, hydrogen, and oxygen. In either of these cases, the products are carbon dioxide and water. Let's try an example. Write the equation for the complete combustion of 2-methyl-2-pentene. Well, first, let's draw the structure of 2-methyl-2-pentene. Here we have 5 carbons in a chain, and beginning with carbon number 2, we have the double bond indicated by the -ene suffix. And then, off of carbon number 2, we also have a methyl group. There's our structure. Now what we need to do is we need to count up the atoms that are on that, and then use the equation to show a combustion reaction. Let's count up carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms. And how many hydrogens? Starting from the left, we'd have 1, 2, 3, and then down on the bottom, 4, 5, 6. There are no carbon atoms connected to this carbon because all of the hands are connected to other things. So we're at 6 hydrogens so far, 7 because there's one hanging off there, 8, 9, 10, 11, 12. So there are the reactants, and the products are going to be carbon dioxide and water. And now we just have to balance this. I see 6 carbons on the left, so I'm going to put a coefficient of 6 in front of the carbon dioxide. We see 12 hydrogens on the left, which means we need a 6 in front of the water. And now we need to count up the oxygen atoms. So I've got 12 oxygens in the carbon dioxide plus another 6. That's 18. So we need 9 O2s. Let's try another one. Write the equation for the complete combustion of ethyl butanoate. The name indicates that we have an ester, and an ester has a particular structure. And here, since we have butanoate, we know that we have 4 carbons in that ester-like group. And then in front, at the beginning of the name, you see we have the prefix ethyl, which is the thing that is connected to that oxygen. We have a 2-carbon group on the right side of this molecule. So there's ethyl butanoate. Let's count up atoms. We've got 4 carbons in this chain. That's what the butanoate. So we got 4 there, plus another 2. That's 6. 6 carbons. Obviously 2 oxygens. And then starting from the left, let's count up hydrogens. 1, 2, 3, 4, 5, 6, 7. None there. None there. So we're at 7 so far. 8, 9, 10, 11, 12. I haven't put those in any particular order, but we definitely have 6 carbon atoms, 12 hydrogens, and 2 oxygens. Our products are carbon dioxide and water. So let's balance this. I see 6 carbons on the left, so let's put a 6 in front of the carbon dioxide. I see 12 hydrogens on the left, so let's put a 6 in front of the H2O. And then let's count up oxygen. 6 times 2 is 12, plus another 6, that's 18. But on the reactant side, I already have 2. So I only need 16 more to equal my 18 on each side. Substitution reaction is our second type of reaction. In this type of reaction, a hydrogen atom is removed and something else is put in its place. Specifically, in the halogenation reaction, it would be a halogen atom that replaces an H. But there are any number of substitution reactions. Let's write the equation for the reaction between ethane and chlorine. A hydrogen is going to be taken off and a chlorine is going to be substituted. It doesn't really matter which hydrogen we remove at this point. We have simply taken a hydrogen off and bonded it to the other chlorine, and we've substituted the chlorine in its place. If we provide more chlorine, then there will be more chlorine atoms that are substituted onto that chain of carbons, and in theory you could put basically any number of chlorines on there, just keep adding chlorine as a reactant. So that's a substitution reaction. Substitution occurs with aromatic compounds as well. Here we have benzene as a reactant in both of these reactions. You remember that around the outside we have one hydrogen connected to each of these 6 carbons. One of those hydrogens would be removed. It would bond with the other bromine atom, and we would put a bromo group on that benzene molecule. And if we add more bromine, you could potentially put additional BRs around the outside at certain locations. Similarly, with the next one, we're going to remove an H and put an ethyl group in place of that H. We're going to substitute an ethyl group. There's the ethyl group so you can see the atoms, and there's the ethyl group in shorthand notation. Let's summarize Organic Reactions 1. In this lesson, we went through 2 basic types of reactions that occur with organic molecules. 1. The complete combustion of hydrocarbons, or of compounds containing only C, H, and O, produces carbon dioxide and water. 2. Substitution reactions end up removing an H and replacing it with something else. In halogenation, a halogen atom is substituted in place of a hydrogen atom.